So why do we have to do math in physics? Why do we have to do math? What's the purpose of mathematics? A lot of people absolutely hate math. So why take something interesting and then make it really, really dull and boring? What's the idea behind it? All right. Why do we have to do math? All right. So here's the reason why we end up doing a lot of math. Get back to the scientific method. All right. So whenever we come up with theories need to make testable predictions. And then we have to do experiments. And then obviously theories, if they're mathematical, they will give you numbers. And if the experiments come up with something that you can measure, they will also give you numbers. Okay, hold on. I need to get something. Okay. Okay, guys, can you see the ball? Of course you can, right? Notice that when I drop the ball, it just falls down. It's just going down. Okay, and it falls because of gravity. You guys kind of guessed that correctly previously. All right. Having said that, when the ball is falling, does it fall at a constant speed or does it accelerate? Does anybody know? So the falling ball, does it fall at a constant speed or does it accelerate? What do you guys think? All right, can you tell by looking though? All right, so you guys are thinking that the falling ball is going to accelerate. Some of you guys will say, no, it's falling at a constant speed. Some of you guys will say it's accelerating. You really cannot tell by looking, right? Obviously, it's just gonna, as soon as you drop it, obviously it's going to fall. So is it going to accelerate? When I say that the falling ball, is it going to fall at a constant speed or is it going to speed up? You cannot tell by looking. Absolutely not. Things happen way too fast. We're not dealing with anything complicated. We're still, this is not time travel. This is not parallel universes. This is not black hole. This is just a ball falling. It's a linear, straightforward motion, and you still cannot see the details of this one. So why we need math? The reason why you need math is because a lot of the nature is invisible to us. We are dealing with electrons, the motion of which is going to give you current, electricity, out of electricity. Obviously, you have these computers, you got the TVs, you got your cell phones, and everything that you're dealing with is based upon the technology created by particles that we cannot directly see. It's kind of weird. Or you may be looking at the entire universe, guys. Much of the universe is invisible to us. Imagine that. Or the stuff that you can see, you still cannot see the details of this motion. So what do you need? Is this object falling at a constant speed or is it speeding up? You can't tell. So what you need to do is you need to come up with a theory, which is going to make predictions. All right. One theory says, hey, it's going to fall at a constant speed. If it's falling at a constant speed, it's going to make some numeric predictions. The other theory is going to say, hey, this thing is going to speed up. So once again, it's going to make some numeric predictions. And when you test, the test will also give you some numbers. If the numbers match, theory is good. If the numbers don't match, the theory is no good. So do you understand the reason why everything is so mathematical? Everything is mathematical because you cannot see the details of a lot of the stuff that makes up nature, guys. So theory is going to give you numbers. The experiments will give you numbers. If the numbers match, the theory is good. If the numbers don't match, you got either the theory is wrong or you messed up the experiment. It can go either way. So what's the purpose of math? It's to make predictions. It's going to make numeric predictions. You get numbers from the theory, you get numbers from the experiment. And if the numbers match, then we're good. If the numbers don't match, then either the theory is wrong or the experiment is wrong. All right, so that's how it is done. That's how the game is played. All right, so speaking of numbers, I'm going to write down the same number 3 times. It's going to be 3.5748, and then I'm going to write down 3.5748, 3.575, and then I'll go 3.58, and then I'll make it 3.6, and then I'm going to make it 4. Okay, cool. Okay, so take a look at the numbers. You got this number and you got that number. How many of you guys noticed that I end up writing the same number 1, 2, 3, 4, 5, and 6 times? Okay, it's the same exact number, guys. All right, so I end up rewriting the same number 6 times. That's what I did. Okay, this one is the least accurate. This one is the most accurate. In terms of accuracy, you can make it this accurate or you can make it this accurate. It doesn't matter. The sort of accuracy that we will go for is going to be to the 10th decimal usually, or the 100th decimal. Okay, so these are the ones which are acceptable at this point. Okay, so what do you need for that? Any calculator will work. It doesn't matter. As far as I'm concerned, as long as you're in the ballpark, I'm happy. Okay, so right after the decimal, if your numbers are different from mine, it's not a big deal. None of you guys are going to be working for NASA anyway. So a lot of these calculations, just be in the ballpark. That's what I'm going for. Now, speaking of numbers, life kind of gets interesting because the numbers without units, they don't mean anything in physics. So let's talk about the units. There are two types of unit system in the world. One of them is called the British unit system, and the other one is known as the metric unit system. So we got two types of unit systems. One of them is the British unit system. That's the one we use in the United States, and the other one is the Standard International System, or otherwise known as Standard International. I probably misspelled the standard. All right, so Standard International Unit System. So this is otherwise known as the SI unit system. Okay, so let's just copy this down. All right, so speaking of the Standard International as well as the British unit system, what's the difference between these two unit systems? So let's just emphasize that. So you got the British unit system, and we also have the International unit system. British unit system is something that we are all used to. Case in point, 1 foot, how many inches?
12.
Yeah, it's 12 inches, so give yourself 2 points for that one. So 1 foot is going to contain 12 inches. And so the next question is 1 mile, if that's the case, how many feet? Okay, how many of you guys would know the answer without looking it up?
Is it 2,500?
Yes, I'm going to give you 5 points for saying something. So the reason why I'm giving you 5 points is because at least a few thousands, that's correct.
I bet the number
But that's not the right answer.
5,000 is too easy.
Okay, that's more like 5,000 and 200 and anybody? So we got 5,200, and at this point, what happens is you go blank, right? You can look it up, obviously, and when you look it up, this is what you end up getting. All right, so it's going to be 5,280 feet. That's what you end up getting from me. All right, so, okay, so let me ask you this question. Every single person in this room knew that 1 foot is 12 inches, so why is it that you guys kind of struggled with 1 mile being 5,280 feet? Okay, so what caused you to struggle?
More digits.
Okay, say it again, more digits, that's not bad. I'm going to give you 5 points. It's not that it's got more digits, it's that what's the real reason for it?
You don't really calculate miles and feet. It's always just done by miles. You use the bigger unit.
Something is a mile. You don't realize, you don't go, wow, I wonder what it is in terms of feet. We hardly use that information on a daily basis, so I'm going to give you 5 points. Chantal, I'm going to also give you 5 points. Yeah, guys, there's a couple of reasons for it. Number one, it's not because you're stupid. It has nothing to do with it, because you guys can handle big numbers. I know you remember your social security numbers, right? It's huge. You remember it. You remember your cell phone number. Stuff that you use, you will remember. You don't use it. There's absolutely no reason to use something like that. If you have to go more than a mile, what do? You drive. You don't walk. Most of us don't. Or you get back on top of your horse. No one walks today. A mile, unless you're exercising, I don't think so. It's a waste of time. In fact, you would drive. While you're driving, you don't even think of distances in terms of miles. You think of distances in terms of minutes. All right. So when I was working in Schaumburg, I live in Bartlett. It's like, I don't know, it's 20 minutes. 20 minutes on a good day. If it's a Monday morning, forget it. It's 40 minutes. Despite the fact that it's the same distance, it's 10 miles. All right, so that's what we do. The reason why you don't remember this number, look at the freaking number. Make it 5,000 feet, even the homeless would remember, but no, it's not. It's 5,280 feet. That's a weird combination of numbers. Why? The Romans came up with it. The idea of a mile is a Roman invention, and Romans, they had an empire. These guys are smart. They said 5,000 feet is a mile. 5,000 feet is a mile. That you can remember. Got it? And British, they kicked the Romans on. And they say, oh, let's add 280 feet to it and confuse the hell out of everyone. So we know who the Romans are. Numbers are nonsensical. 12 inches, 1 foot. Why? That's a weird thing. Why not 14 inches or 15 inches or 20 inches or 10 inches? 5,280 feet, 1 mile. Why not 5,000 feet or 10,000 feet? Numbers simply don't make sense. Now, the British unit system it's got its own problems. Standard International unit system does away with this complication. So what it's a metric system in essence. So the base unit is a meter. So we got your meter. You can take a meter and divide it into 100 smaller pieces. These are known as centimeters. You can take a centimeter and divide it into 10 smaller pieces, which are known as millimeters. Or you can take 1,000 meters and call it a kilometer or kilometer. It's the same thing. Notice that everything is a factor of 10. Everything is a factor of 10. So Standard International unit system is logical. Everything is a factor of 10. Base unit is a meter. Breaking into centimeters. Centimeters can be broken into millimeters. And meters can be expressed in terms of kilometers. That's how it is. It's nice. It's beautiful. All right. With the exception of 3 countries. No one used the British unit system. No one else used the British unit system. Obviously, we use it in the United States. The second country that uses it is not Canada. Canada will have the British unit system on the side in case people are visiting from the United States. And Britain is not the third country either. There are 2 other countries which are too small enough so that I don't remember their names, but the United States is the only major country that uses it at this point. Okay, So what's the advantage of standard international unit system? Let me ask you this question. Which unit system do you think is more accurate? Is it the British unit system or is it the standard international?
Standard.
All right, I'm going to give you 2 points for answering that question. That's a misleading question, right? Because I kind of forced you to pick one over the other one. Both of them are just as accurate. British unit system versus the standard international. In the standard international unit system, the smallest unit that you can come up with is a millimeter, which is the same as 1/20th of an inch, guys. So 1 millimeter is the same as 1/20th of an inch. Okay, so they have the same accuracy. If they have the same accuracy, so why not use the standard international unit system? Why do we use the standard international unit system if they have the same accuracy?
It's simpler.
Simpler, beautiful. Give yourself 5 points. It's simpler, guys. You don't have to memorize these weird numbers. Like, oh, this number that you can never remember. It's simpler. Everything is a factor of 10. It's beautiful. All right, except this is going to become a problem for us. The problem is we're used to using the British unit system. Yeah, in sciences, we use the standard international unit system. We use the standard international unit system. So that's going to cause some problem. Okay, case in point. Imagine that I'm driving my souped up Ford Tempo, which happens to be a car you've never heard of before, more than likely, which you will for the rest of your lives. I'm driving it in a 30-mile-per-hour zone at a speed of 26.78 meters per second. All right, so this is how fast I'm driving. So the question is, if I were to get caught, would I be getting a ticket? All right, so my speed. So I'm driving at 26.78 meters per second in a 30-mile-per-hour zone. Would I get a ticket if I were to get caught? So what do you think? All right, so I know what you guys are thinking. It depends on the conversion, right? All right, if it's a 30-mile-per-hour zone, given the fact that I'm going at a speed of 26.78 meters per second, would that number be less than 30 miles per hour or more than 30 miles per hour? Okay, so it completely depends on the conversion factor. So what is the conversion factor? Conversion factor in this case is how fast a meter per second is in terms of miles per hour. All right, so if you are going at a speed of 1 meter per second, how fast would that be in terms of miles per hour? Okay, so this is known as a conversion factor for speed. All right, so this is the conversion factor. So 1 meter per second in this case. All right, speed conversion factor. Oh my God, this is so much fun. All right, we will have the conversion factors on a formula sheet. Okay, as soon as I get a chance, I'm gonna put the formula sheets and everything else online so you can actually see them and use them. All right, so given the fact that if you're going at a speed of 1 meter per second, that would be the same as 2.24 miles per hour. Do you think 26.78 meters per second in terms of miles per hour, do you think it's going to be larger than 30 miles per hour or smaller than 30 miles per hour?
It is going to be bigger.
It's going to be bigger. Give yourself 2 points on that one. So now, conceptually, intuitively, you know it's going to be bigger. All right. So let's check to see what number we will get for that. All right. So let's do a conversion. I love the way the chemists do their conversion. So I'm just going to steal the way these guys do it. I'm going to take this number, 26.78 meters per second, and convert it to miles per hour. All right, so what I do, whatever the unit that you see here, just place it at the bottom, and whatever it is that you're trying to convert it to, just place it on top. All right, so meters per second is going to take 1 in front of it. Miles per hour is going to take 2.24 in front of it. All right, so we got 2.24 here, we got 1 there. Okay. The next step is just cancel the like terms. All right, so these two will cancel. And the surviving unit is going to be that. So what do we have? This number is going to multiply that number. And that's going to be the proper unit. All right, so we'll do that. And when you do that, it's going to give us 60 miles per hour. All right, so I'm going to make this example number 1. All right, so that's 60 miles per hour. All right, so moving forward, let's do one more example. This time I'm going to write the number in terms of miles per hour. All right, so it's 773 miles per hour. Does anybody know what this number represents? Does anybody know what this number represents? Any ideas?
Is that the sound barrier?
Okay, beautiful. I'm going to give you 5 points for that one. So does anybody know what that number represents? It is the speed of sound. I'll give you 5 points for that one. That's beautiful. It's the sound barrier. It's otherwise known as the speed of sound. Okay, very good. So let's express this in terms of, how did you even know that?
I believe I watched there was like some video that I watched back forever ago where it's like some guy on a land vehicle breaking the sound barrier.
Beautiful. I'm gonna give you 5 points for that one. We'll probably watch the same video again, and we will run some calculations on that one. All right. It's probably gonna be our conceptual lab this week or the following week. Okay. So the first thing I'm gonna do, once again, just grab the unit, just place it here, and whatever the unit that you're converting to, just place it on top. All right. So miles per hour is gonna be at the bottom, and meters per second is gonna be on top. All right, so miles per hour is gonna go to the conversion factor. So just grab the number from there, and meters per second is gonna take that number. All right, so 1 meter per second is 2.24 miles per hour. And get rid of the like units. Okay, so once again, this number is gonna multiply the numerator, and then everything gets divided by the denominator. Okay, so do the calculation. So this should give you 345.08, I think, meters per second. All right, that's it. So we will be doing tons of conversions, and this is how the conversions are done. Okay, so let me just come up with a summary statement. My summary statement is going to be like this in terms of conversion. So this is the unit that you're converting from. All right, so whatever it is that you're converting from, just place it at the bottom. And whatever it is that you're converting to, just place it on top. All right, so that's how we will do stuff. All right, so cool. So what do we know? We got the numbers, the sort of accuracy that we will go for. All right, so this is too small. Okay, so this is okay, so it's this one. We talked about the difference between the British and Standard International. Standard International is what we use because conversions are much easier, so you don't have to worry about memorizing stuff. Because we still use the British unit system in the United States, and in sciences we will use Standard International, we have to do conversions. Okay, so we got 2 examples of conversions, and you will have to work with a conversion factor, and the conversion factor is usually go here. Okay, so from, to, that's how we set them up. Okay, so that's a brief review of how we will do these conversions. All right, the next step that I'm gonna go is algebra. Okay, simple algebra review. Okay. We will just do the basic algebra. Okay, more than likely, unless you're fresh out of high school, your algebra skills are probably going to require a little bit of work. It's not a big deal. You can always get better at algebra and physics. So if you find yourself struggling a little bit, it's not a big deal. Just ask me questions. All right. I'm usually available right after the lecture, so it's not a big deal. We can go over the stuff that you need. All right. So here's what I'm going to do. There's 6 things that I want you to be able to do really well. Those are the 6 things that I'm going to cover. Let me start out with something real easy. So 3x equals 6 semicolon x. Okay, so this semicolon x thing is my thing, which means that I want you to isolate x. Okay, so anything after the semicolon is what you need to isolate. So how do you get x all by itself? Okay, so at this point you guys know the answer, so tell me what it is that we need to do. You get x all by itself by getting rid of 3, right? So how do you get rid of 3? So you divide both sides by 3. That's what you do. All right, so give yourself 2 points for that one, and then we're done. Okay, now this is the way you would do this sort of stuff in high school, which is fine. Except I'm not going to let you guys use numbers. Instead, we will get to use symbols because we will use a lot of formulas. All right, so a lot of the work is going to get done symbolically. All right, so I want you guys to kind of get used to doing stuff using symbols. All right, case in point, we'll get to do the same thing this time using symbols. A times x equals b. I want you guys to isolate x. So how would you do that? Okay, once again, it's the same thing. Just get rid of a. So both sides are, give yourself 2 points for that one. Dividing both sides by a, right? Okay, so this is known as symbolic algebra. It's so much easier. It's not as crowded or cluttered because you don't have to worry about numbers. All right, we will use the numbers at the very end usually, but let's just go through the algebra. All right, here's a physics formula. We were talking about forces last time. Force is what causes acceleration, guys. Okay, you don't need to remember it right now. I just want to show you that the ideas are expressed using symbols. F is your force, m is the mass, and the mass is what accelerates if there's a force acting on it. So how would you isolate A? All right, so one of the first things I'm going to do is I'm going to rewrite this formula, get down on the left-hand side. All right, so I end up switching sides. And the next step is I'm just going to, boom, get rid of m by dividing both sides by m. So that's what we will get to do. So m is going to divide both sides, and we are done. All right, so a equals f divided by m. Boom. Okay, so what I did is I took a concept that you guys are actually good at from algebra, high school algebra, and then expressed it using symbols. And then I showed you an example of how we do it in physics. Okay, so this is an actual physics problem. All right, so that's the method number one. I'm going to call this method number one. So I'm going to move on to the next page. I'm going to give you a second method. All right, this one is going to be just as simple as the first one, except now we got x divided by 4 equals 3. Isolate x. Okay, so how do we do this one?
Multiply by 4.
Okay, give yourself. Multiply both sides by 4. All right, so 4 is going to multiply both sides. On the left-hand side, you get your cancellations. So it's going to give you 12, and then we are done. Okay. All right, so let's have a generic example. Let's have a generic example from this one. Okay, so x divided by a equals b. Isolate x. Multiply both sides by a. So a is going to multiply both sides. All right, so x is on the left-hand side. On the right-hand side, you have b times a, which is the same as a times b, and we are done. All right, let's come up with an example from physics. All right, so speed is distance over time. Solve for distance. All right, the first thing I'm going to do is I'm going to rewrite the formula, get the unknown on the left-hand side, and then multiply both sides by the denominator. So t is going to multiply both sides. And okay, that's it. So the distance is speed times time. All right, so this was a simple example of the second one. The third one is going to be just as simple. In fact, I think most of you guys will be able to do this in your heads. Boom. And then what I'm going to do, I'm going to show you a shortcut regarding the third method. All right, so we'll do 5. Make this 15 divided by x equals 5. Okay, what I'm going to do, let me just change this into a multiple choice. And I'm going to give you a bunch of numbers. Okay, so we got that. All right. What do you guys have? What's the best one? Is it A, is it B, is it C, or is it D?
C.
All right, those of you guys who pick C, give yourself 5 points. All right, I mean, C is the best answer in this case. Okay, so let me ask you this question. Those of you guys who pick C, how did you do it?
Well, personally, I just multiply that x to the other side and then divide it by 5.
Jack, I'm going to give you 5 points for that one. Most of you guys would just multiply this and then divide both sides by 5. And so it's going to give you 3. That's the way you would do it. All right, so instead of doing it that way, what I'd like you guys to get used to doing, okay, then I'm going to give you 5 points as well. So it's a bit of a working out there. All right. When the unknown is in the denominator, take a shortcut, just switch. Okay, that's actually a neat way of doing it. So remember, guys, this is not a math course. Physics, the mathematics is like a language. Sometimes, when possible, we'll take shortcuts. So this is one of the shortcuts that we will get to take because it makes life so much easier. Okay, so what we will do is we will just switch those two terms. That's it. Okay, so we'll be lazy, switch those two, and as soon as you switch those two, this is what you end up getting. All right, so let's do one generic and one physics. All right, so this is going to be our generic. All right, so I have A divided by X equals B, sum for X. Boom, just switch. So we will switch those two. So A divided by B is going to be X, or I'll say X is A divided by B. Okay, that's it. Okay, so let's do a physics example. Part B is going to be our physics. A and B. All right, acceleration is how fast the velocity changes in time. So v minus VO divided by t is your acceleration. T is your time. All right, so isolate t. All right, unknown is in the denominator. Switch. That's it. So t is going to be v minus VO divided by a. That's it, guys. It's a beautiful trick. This is going to save us tons of time when things get complicated. All right, moving on. 4 is going to be just as simple. 4 is going to be just as simple. Let's move on to 4. Okay, so most of you guys should be able to do this stuff in your heads. Okay, let me just make it up. 3x minus 4. It's going to be 8. Sum for x. All right. Most of you guys don't even have to do the work. Tell me what you guys came up with.
You're going to add 4 to 8.
Okay, I'm looking at the answers. Some of you guys are actually writing it out. I see a lot of 4. So
4.
you guys who came up with 4, give yourselves 5 points. Notice that you guys are so good at this stuff. You didn't even have to think about it. As soon as you see it, you know, the way to do it is obviously you add 4 to both sides. All right. So let's do that. Let me show work here. 3x minus 4. All right, so get rid of 4 by adding 4 to both sides. Let me do it the proper way of doing it. And then I'm gonna show you the way we do it in physics. So you end up getting 12. Get rid of 3. Okay, so you got your cancellations. So it gives you 4. All right. The way I would do it normally, instead of just adding 4 to both sides, when you move terms across the equality sign, I'm just going to change signs. All right, so you're trying to isolate this. You got -4. If you move -4 here, it's going to become +4. So that gives you 12, and then you divide it by 3. Okay, so that's the way I would do it. That's the way we would do it in physics. Except I had the misfortune of teaching algebra at some point, and the algebra instructors absolutely hated me for taking these shortcuts, okay, because that's not the proper way of doing it. I get it, but that's how we do it in physics. So either way you do it, this is how it is done. All right, so this brings us to the next point. So let's do one generic and one physics problem. In fact, we'll do a few from physics. All right, so a times a times x equals a times x plus b equals c. Solve for x. So what do we do? All right, I'm gonna do it my way. Move this across. All right, so when you do that, it becomes negative, so it's c minus b. Okay, so what's the next step? Get rid of a by dividing both sides by a. Okay, that's it. All right, so let's do our generic physics. No, this was a generic math, so let's do 2 physics ones. I'm gonna give you one simple and one slightly challenging. All right, simple one goes like this. V squared equals VO squared plus 2 times a times x. All right, solve for a. All right, tell me how to do this. Right, yeah, go ahead.
Sorry, wouldn't it be v squared minus v sub 0 squared divided by 2a?
Or 2x, right? All right,
Oh, divided by 2a.
Gonna give you 5 points on that one. All right, let's do it together. The first thing I'm going to do, I'm going to rewrite this because I want to get the unknown on the left-hand side. And a's are unknown. All right, so this is what we're solving for, so I'll get rid of this by subtracting it from both sides. All right, so these two will add up to 0. And this gives you 2 times a times x. So you have v squared minus VO squared. And then now you can get rid of 2. And you can get rid of x. That's it. So v squared minus VO squared divided by 2x. All right, so let's do one more. Okay, the next one, I'm going to make it slightly challenging for you guys. All right, so C is, I'm going to have x equals VO times t plus 1/2 AT squared. All right, this time I want you to solve for A. All right, just work on it briefly, and then we'll do it together. And so that's the last one that we will do for now, and then we'll go take a break. All right, so this is 4. All right, guys, let's do it together. The first thing I'm going to do, I'm going to rewrite this so the unknown is on the left-hand side. All right, so I'm moving things around, so unknown is on the left-hand side. All right, Patricia, okay, I see what you did. Okay, I'm going to give you 5 points for doing it. I'm not sure if that's the right one, so we'll find out. Okay, the next thing I'm going to do is, what is it that we're isolating? A is what we're trying to isolate, so it's here. So why not just get rid of this entire term? So you can just move it across, so it's going to be negative, or just subtract it from both sides. It's the same thing. All right, so they will add up to 0 if that's the case, right? Okay, it seems like this time, then you may have gotten it right. Yeah, I think that's right. All right, give yourself 10 points for that one. All right, so next step is this term. Okay, there's 2 ways of doing it. Okay, so how do you get rid of this? And some of you guys go, oh, okay, so I'm going to divide both sides by 1/2. It's fine. In reality, this 1/2 that you're looking at is the same as this entire term is divided by that. Okay, so the way I will do it is multiply both sides by 2, and then divide both sides by t squared. That's it. Okay, so those of you guys who got this on your own, give yourselves 5 points. Okay, guys, a lot of the math that you will do is not going to be any more complicated than this. Okay, algebraically, this is the sort of stuff you will do. I don't like using numbers per se. The numbers is this last thing we will enter into these equations. You guys will get used to doing it, obviously, because we will practice that. But if you can handle this sort of algebra, obviously, you're more than ready for it. Got it? So if you're out of practice, you'll get good at it. You'll get better at it, because we'll do plenty of this sort of stuff. All right. So at this point, what I'm going to do is okay, guys, moving forward. Hey, 2 more. We got 5, and let's do 5. Okay, so 5 is going to be easier than 4. What if you have a square? What do you do with that? How do you get rid of a square? Yeah, you got a square with both sides, right? Okay, so that's what we'll do. Square root of both sides. When you take the square root of both sides, this is going to give you 3 plus or minus. All right, so you got 2 options. For the most part, we will end up taking the plus. So don't worry about the signs at this point. All right, so let's do a generic one. Ax squared equals b. Solve for x. Get rid of a from both sides. And the last step is get rid of the square. So it's going to be b divided by a under the square root. Let's do a simple one, and now let's come up with a challenging one. The simplest one is Einstein's famous equation mc squared. Solve for c. I'm going to rewrite both sides. and then get rid of m. And then take the square root of both sides. All right, so here's the final equation. Okay, let's do one challenging one. Okay, I'm gonna give you two. One is gonna be challenging and the other one is gonna be kind of cute. All right, challenging one is this one. So we got v squared equals vo squared plus 2 times a times x. Solve for vo. Okay, so how do we do this? Okay, so I'm gonna rewrite this. All right, so VO is what we're trying to isolate. So you got this entire term here. So what you can do is you can subtract that term from both sides. So this term could be subtracted from both sides. All right, so they will add up to 0 on the left-hand side. And then take the square root of both sides. Okay, so this is where most of you guys kind of get into trouble. So what's the next step once you get to this point? Some of you guys either, okay, so obviously you get your cancellation here. Some of you guys say, okay, so you leave it like this. And some of you guys take it one step further and you do it this way. Okay, so you got your VO here. All right, so let me ask you this question. Is it A or is it B? Which one is the best answer?
A.
All right, so at least one person said A. Okay, so those of you guys who like A better, why do you guys like A better? What's wrong with B?
Because B could be plus or minus.
Okay, I'm gonna give you 2 points for that one. All right, what's wrong with B? Does anybody? B, is it under the root?
We square root the whole equation, v squared minus 2ax, not just that 2ax.
Okay, so why not?
So that's why B is incorrect.
Okay, so B is incorrect because you have to leave everything under the square root?
Yeah.
Okay, I noticed that because a couple of you guys wrote the same thing under the chat, in the chat. So those of you guys who made that comment, I'm gonna give you guys 5 points. Okay, here's where you guys get into trouble usually. All right, this term that you're looking at, obviously you got the cancellation on the right, so both of them have the same cancellation. And some of you guys leave it as is on the right-hand side, and some of you guys take it one step further. The way you take it one step further is you take this term. All right, let me just grab this, show you something. You say, okay, so I'm gonna take the first term, and I'm also gonna take the second term. So you take a square root and divide it across each and every single term. You end up getting this cancellation. As a result, it's gonna look like this. All right, this is the same as this. Okay, can you do this? Yes or no? Can you take a square root and then split it across a negative or a positive sign? Okay, so the answer to that question is no, right? So the math is not gonna allow you to do that. So some of you guys are keen on this and some of you guys kind of get confused. Yes, this is as far as you can go with this. This you cannot do. All right, I see this on the test. Okay, that tells me that some of you guys are kind of out of practice, but this is as far as you can go with this. Okay, next one is gonna be cute. When I say cute, that means that it's gonna be challenging for you guys, okay? In a weird sort of way, you kind of know how to do it, but somehow you're not gonna be able to remember it, not today. I may be wrong, but usually 99% of the time, students usually don't know what to do. All right, so this one is gonna be the cute one. So let me just give you something first. It's gonna be, all right, move x. All right, VO times T plus 1/2 AT squared. Solve for T. All right, so just give me an idea. Does anybody have anything at this moment? All right, tell me what to do. Make some suggestions at this point. So you have T here, you got T here. I want you to isolate T. What do you do? How do we do something like this? Anybody?
Factor out a T.
All right, so factor out a T. I'm gonna give you 2 points for that one. So what would happen if you were to factor it out? You can only factor out 1T and then 1.
Well, I started looking back further, and we have that A is equal to V minus VO over T. And using that, we can get rid of that T we have in the T squared.
Okay, so you said, did you end up using this?
Yes.
And then you plug it into that. Oh, that's cute. You end up doing that. All right, so you said, okay, I'm just gonna use this. All right, let me just hold this, and then you put it right there. And then you end up getting one of the T's. And then what? So in other words, you end up using some substitution method. Okay, that's actually cute. I'm not gonna use that. Let's stick to algebra. How do you do something like this? All right, guys, you know how to do this. Unfortunately, once again, I end up conditioning you to thinking a certain way. And now you're not able to get to what you previously, the stuff that previously you learned in high school. You have T and you have T squared. All right, so T is raised to the second power. So guys, this is known as a quadratic equation, so which requires that you use the quadratic formula. All right, this equation in essence is the same as this equation, remember? If that's the case, what do? You end up using the quadratic formula, which is what?
That's x equals negative b plus or minus the square root b squared minus 4ac over 2a.
Okay, so when you have a quadratic formula like that, all right, so you have some number raised to the second power of x, and you have some number in front of x, and you got c. All right, so this is x squared, this is t squared. A here is the same as 1/2 a here. This is like the x here, and this is like b, and then you have some kind of a c, which is this, whatever that is. So we'll get to it. Okay, so let's write out the quadratic formula. So what is x? It's going to be b plus and minus, what is it? It's going to be b squared minus 4ac, right? And everything is divided by 2a. Okay, so this requires a quadratic formula. Okay, so what I'm going to do for something like this, and we may end up using this once or twice this semester. So this one is a really good review. I'm going to make this look like this formula first. Okay, so ax squared is this portion, bx is this portion, and then you have your c. So I need to move c here somewhere, and then everything is going to equal to 0. Yeah. All right, so I'm going to rewrite this equation here. So it's going to be 1/2 a t squared plus VO times t. And then when you move this across, so this is going to be negative x, and then you will have 0 here. So it's negative x, it's going to equal to 0. Okay, so let's play with the equation. So this a that we are looking at is going to be this. Change color. B that we're looking at is going to be that. And C that we're looking at, all right, so let me just change this. Let's make this plus, and there's a negative sign. I'm going to put a negative sign there. All right, so this term that we're looking at is the same as this term. All right, so what do we do? Everything that you see here needs to be substituted into that equation. So x becomes t. B here is the same as VL. We got plus and minus. B squared is going to be the same as VO squared. And then we have negative 4. this A is the same as half an A. And what else do we have? We got our C. C is going to be the same as negative X. And everything is going to be divided by 2A. Okay, once again, A is the same as half an A. Okay, so what do we have? We got cancellations and simplifications, right? I think you guys know where we're going with that. So this is how it is done. So you have BO squared. All right, 4 divided by 2 is going to be 2. A, okay, and what else do we have? Okay, so you got a negative here, you got a negative here. Negative times negative is going to be positive. X under the square root. And these two will cancel. Whoops, I made a mistake. That's it. It's a little bit of work, but you guys kind of knew how to do this from high school. All right, so that's the quadratic formula. This is how you use it. The reason why we were able to do that is because this is raised, t is the unknown, this is your variable, raised to the second power. That means that it turns into a quadratic equation. If it's a quadratic equation, use the quadratic formula. That's it. All right, let's do one more. All right, the next one that we will do is going to be fairly easy. So let's make it, call it 6. What if you have some like this, x square root 4. All right, so how do you get rid of the square root? All right, guys, just square both sides. Okay, so that's it. Okay, let's do one generic and one cute. Generic one is straightforward. Ax minus b equals c. All right, isolate x. All right, so how do we do this? Square both sides. So we get square and square root will cancel. All right, this is going to give us a times x minus b. Okay, give yourself outputs, that's correct. Okay, and add b to both sides. Okay, so what do we do? Get rid of a. All right, so that's as far as we will, as far as you're going to be able to go with this one. Okay, so let's do something a little bit more challenging. Some a little bit more challenging. All right, let me give you a terminal velocity formula. Okay, make this C. Sum for C. All right, so this one is a Greek letter, rho. You got your A, you got your C, so isolate C. All right, guys, so let's do it together. The first thing I'm going to do is just get rid of the square sign. I get rid of the square root by squaring both sides. All right, so here's your terminal velocity squared. 2 times W You got your rho, you got your A, and you got your C, and C is what you're trying to isolate, right? So how do we do that? I'm gonna employ the trick that we used before. You can actually switch both sides. Because everything here is a multiplication, you can also just grab these two terms and switch them. Okay, if there's multiplication, you can do that. So I'm just gonna switch those two terms. And that's it. So C is gonna be 2 times W, rho A times VT squared. I noticed that one of you guys already got that. So those of you guys who got it already, give yourselves 5 points. So that's good work. Okay, that's it. Okay, so algebraically, these are the 6 different things that you should be able to do really well. And if this is the sort of stuff that you struggle with, not a big deal. You'll simply get better at it. Okay. The next one that I'm going to do real quickly is trig, and then let's do a quick trig review, and then I'm going to let you guys go. What I'm going to do in terms of trig, the simple trig, nothing complicated. I want you to know sines, cosines, and tangents. All right, so everything comes out of this right angle triangle. All right, so you will have the base, you will have the height, and you will have the hypotenuse. You got your base, you got the height, the hypotenuse. Okay, hypotenuse, base, and the height are going to be related to each other in the following fashion. All right, so the square of the hypotenuse is going to equal to a squared plus b squared. So square of the base times the square of the height is going to give you the hypotenuse. So this is the basic fact. A simple equation. All right, so this thing is true for right angle triangle. So that's it, right angle triangle. Now let's introduce some angles here. So theta is going to be our angle. In terms of theta, you can compare the base length to the hypotenuse, or you can compare the height length of the hypotenuse and express it in terms of the angles. Okay, so there are 3 things to consider. One of them is called the sine of the angle. Sine of the angle is going to be the opposite over the hypotenuse. The other one is known as the cosine of the angle. This one is going to be the adjacent over the hypotenuse. And the third one is known as the tangent of the angle, which is simply opposite over the adjacent. All right, so the height over the base. And then what you need to be able to do is you need to be able to figure out the angle based on these. Okay, so how do you get the angles out of these? All right, so what you need to do is you need to take the inverse of the sine and cosine and tangent in order to get the angles for these. Okay, guys, it goes like this. If you take the inverse of the sine, b divided by a, it's going to give you the angle for that one. Cosine of a over, okay, b over c. I made a mistake here, getting too tired here. Okay. And the inverse of the tangent of b over a is going to give the angle. So there are 3 ways you can come up with the same angles. Okay, so these are your trig functions. In terms of the trig, one more thing that you need to know is be able to express the angle here. You can also express this in terms of sine and cosine.